Okay, this is chapter 10.1. This will be about the inclination of a line, the angle it makes with the x-axis. So once again, it's about the inclination of a non-horizontal line. Okay, the positive angle counterclockwise from the x-axis to the line. So I don't know if you can see this, so some of this I will just repeat and just make sure you can see what I see. So I'm crossing out the equation and I'm putting it a little larger, y equals x. Now, I am going to go a little faster just because there's no one in this room, so I'm just going to be talking, and hopefully if I go too fast, just rewind it and listen to it again. Alright, so the inclination of this line that you're looking at, it would be from the x-axis to the line. So we will be looking for this angle, because this is going to be the inclination, 20 degrees, 30 degrees, whatever it may be. Now looking at the equation y equals x, and looking at the slope of the equation, 1, with the slope I can see that the line is climbing at 1, and it rises 1, it runs 1, rise 1, and so forth. So up 1, up 1, up 1 over 1, up 1 over 1, like this. Okay, but if I want the angle, I'm going to go back to trig, and trig said if we have right triangles, okay, and if we know the opposite and adjacent side, we can use tangent. So that's exactly what I'll do in this one. Since the slope is 1 over 1, I could use this side as the rise, 1, this side as the run, 1, which allows me to say I know the opposite, I know the adjacent. So I'm going to use tangent, the trig function tangent of theta equals 1 over 1. Theta, if you want to do inverse tangent of 1 over 1, will be, and hopefully you guys remember 1 over 1, the size 1, 1, that comes from your special triangle of 45, 45 with a 1 and a 1. So really we don't need our calculator. 45 degrees is the answer. Okay. The next one, I have to go get my notes. I don't have them with me right now. On this next one, we're going to have to use a calculator. Okay, I've got my notes now. I'm sorry, I wasn't quite prepared. The next one, you're looking at another line, and we want the angle of inclination. Again, it is this angle from the x-axis to the line. That's the angle we're looking for. The equation, I don't know if you can see it, is y equals 2x minus 2. So once again, I'm going to make a right triangle from there to there. And notice the slope is 2 over 1, so the rise is 2, the run is 1, which allows me again to use tangent. So I would do tangent of theta equals 2 over 1, theta equals inverse tangent of 2. Theta, and that's what we're looking for, the angle of inclination, right here, is, using my calculator, 64.43 degrees. This is one where it did not come from a special triangle, so you had to use your calculator. Then, just in case the book is going to ask you for radians, I would take my calculator, I would hit mode, get it in radians, punch it in, and the answer to this one comes out 1.11 radians. Okay? And just a quick reminder, 1.11 radians, the 1 actually means 1 radian. And if you think about it, everybody, this is the radius of your circle, right from there to there. So really, radians is the distance around your circle. So the 1 is 1 radius. So from here to about probably here, that would be 1 radian. And that little extra piece would be the 0.11 radius. So 1 radian is equal to 1 radius. And your angle of inclination is 1.11 radians. Or in degrees, it's 64.43. All right, so what this amounts to, if you want the angle of inclination, is you will be looking for an angle, and the angle right here, da 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 da, boom, M. Whoops, sorry, I messed that up. Let's go a little higher. Let's circle that. It is tangent of your angle that you're looking for is always going to equal M, the slope of your line. So obviously it's very important that we go find M every time. Now the 2 equations I did for you, they were both solved for Y. So as you move on in the slides, you're going to notice they're not solved for Y. Here comes another one. 4x plus 3y equals 12. I think you can see already that the angle of inclination from the x-axis to the line is obtuse. Obtuse, now this will be a harder one for us. Here's the y-axis, just so you know. This will be harder, and you'll see why in just a second. The first thing you have to do, though, is get your slope. Now remember, your angle of inclination is found by taking the tangent of the angle of inclination and set it equal to the slope. Okay, well, solve for y. I get this when I push the 4x over. I divide by 3, and I get negative 4/3 is my slope, and my y-intercept is 4. And as you can see, this is the y-intercept 4, and this is the slope going down. Okay? Now, when your line goes down, it has a negative slope. That is going to tell us we're going to get an obtuse answer. So, we'll do it again. Ready? Tangent of my angle of inclination is equal to my slope, negative 4/3. When you punch in, you're going to have to punch this in. Punch in negative 4/3, you will get negative 53.1 degrees, which is not obtuse. So, you got to think about what happened. The calculator is programmed to tell you inverse tangent of negative ratios in only the 4th quarter. It's telling you to go this way. It's telling you down in the 4th quarter is where tangent is negative. 53.1 degrees downward. Which leads me to believe that this angle right here, is also 53.1 degrees. And since we're interested in only this angle, the inclination, we have to take 180 minus 53.1 degrees and get this answer right here. I believe the answer to that one is 126.9 degrees. Okay? All right. Just a quick shot at this same line. Remember, I crossed at 4. It goes down like this. Now, if you did it in, if you did this in radians, here's that slope again. Negative 4/3. If you did it in radians, the answer is negative, 1 second here. It's negative 0.93, which tells me that right here, around the circle, you have gone 0.93 radians in the negative direction, but we want the angle of inclination right here. We want this one in radians. Okay? Well, you have to understand that this piece right here is the same as this piece right here. Okay, so this going this direction is 0.93. So here's me thinking, if I want this angle from there to there, I have to take the entire half circle, which is pi radians, and just take pi and subtract the 0.93. So what is theta in radians down here? I believe it is 2.2 radians. And that is how you would get it in radians. Okay. Next slide. Okay, we've got a funny looking equation here. Let's solve for y quick. Negative 3y. Push this over. Negative square root of 3 times x. The x is not inside the radical. Minus 3. Divide by negative 3 and you end up with this over this. And divide by negative 3, you'd end up with plus 1. Okay, there it is. Now just a couple things. If you see your equation and you see a positive slope, it's nice to know. This thing crosses at 1, by the way. It's nice to know that the line goes up, and it goes up at a slope of square root of 3, which is about 1.7, right about there, and it goes to the right 3. So 1, 2, 3, and it goes this way 3, and it forms this line right here. Okay, there it is. Now the angle of inclination on this one is from here to here. There's the angle, and I would, if I were you, I would just jump on it anywhere, and it doesn't matter where you jump on it, and just go back to where the line crosses the x-axis. Okay? Now, the slope never changes, so this is the square root of 3 up, this is 3 over, so once again, it's just tangent of theta equals your slope. Right? Well, I guess you can't answer me, you're not here. Okay. Theta equals. Now, again, sometimes these problems, these ratios, they're pretty easy. I mean, if you look right there, you got the square root of 3, so you should be thinking 30, 60, 90s. So let's just look and see which angle it is. Is it the 30 or is it the 60 that would give me this answer? Let's call this 60, this one 30. Let's call this square root of 3. Let's call this 1. And then, of course, a 2. Okay? We want this ratio. So wouldn't it be this opposite side over the adjacent side? 1 over the square root of 3, which rationalizes to that. So knowing that, I'd have to pick the 30. Now, if you don't trust yourself, use your calculator, because that's always going to get you the right answer. All right. Let's keep going, I guess. We got a couple more slides. I want to get 6 slides in. Okay, so what you just learned was the angle of inclination. Now we're going into this next slide. And really what this next slide says is we're going to take any 2 lines. We're going to let them intersect right about there. and we're going to find the angle between the two lines. And there is a formula for this, and this slide and the next slide, all I'm doing is trying to prove it to you. See this right here? That is the angle we're looking for. So how do we get that angle? Well, this is kind of neat how the book did this. The book says, here's the formula to do it, but let's prove the formula first. So I'm just going to prove it to you in this slide and the next slide. So if you don't care about this proof, you move on to slide 6 where the formula is, but the proof is kind of important. So here we go. This angle that this line makes with the x-axis, we call it angle 2. This angle that this line makes, we're going to call that with this angle. This angle is made by the x-axis and this line. We'll call this one angle 1. Now to make this easier, what I like to do is throw numbers in. I'm going to call that 70 degrees. I'm going to call this one 60 degrees. And then I'm going to do something now. And what I'm going to do is I'm going to draw a parallel line to the x-axis. Here's the x-axis. And the parallel line will go right through the intersection up here. Now, why exactly did they do that? Well, they looked at two parallel lines intercepted by a line called a transversal. Okay? Well, if that happens, you know this is 70 degrees, which means this from here to here would also be 70 degrees. And now you also know, let me switch colors, that this line intercepts the x-axis and makes a 60. If I kept it going though, there it goes, it would make a 60 here. Which leads me to believe this angle, right here, theta in between, equals 70 minus 60. Okay, but here's the deal. You really didn't know if this was 70 or 60, so you have to kind of go back to what it really was called, and it was called theta 2, theta 1. So really, how do you find theta? You just basically take, here it is, you take theta 2 minus theta 1, the second angle minus the first angle, and set it equal to what we're looking for, which is theta. Theta is the angle the two lines make. Okay, now what they're going to do, they're going to take this right here, go to the next slide, and then they're going to do something, and I'll show you, and then they come up with the formula. Here's that same thing I just talked about. Second angle minus the first angle gives me the angle between two lines. Now watch what they did. They took tangent of the left side and tangent of the right side. So what you do to one side, you can do to the other side. Okay? Well, then they said, well, you might be asking, why are they doing this? Well, this is the difference formula that you were taught back in chapter 5. You actually worked this out on a test, a quiz. So this is the formula that you used back in chapter 5. Now this still is in front, tangent of theta. Now if you look over here, this is what you and I did on slide 1. We said tangent of any angle is just equal to the slope. Tangent of angle 2 would be equal to the slope of the second line. So every one of those tangents, tangent, all these tangents get replaced with slopes. And this becomes the formula for the angle between any two lines. So what this formula does is it will find any angle, well, not any angle, I guess, just the acute one. We're just going to be finding the acute angle. I'll tell you why in just a second, but for now, let's just say acute is all we're going to find. Okay, last slide coming up right now. Here it comes. Here is the formula we just went over to find the angle between any two lines that intersect. Find the angle between the two lines. Okay, well, to find the angle between two lines, you've got to find slope, slope, slope everywhere. So let's solve for y. Let's solve for y. These are not hard equations. Y equals negative 2x plus 4. Y equals x minus 2. Come on over here. Just call this one, M1 is what? Negative 2. And M2, the slope of the second line is 1. So now, you have all that information. Take this information, plug it into this formula to find the angle between the two lines. Just a quick sketch of these, a quick sketch. It's nice to know, it's kind of nice to know what these really look like. So here I go, I'm going to go, one line crosses at 1, 2, 3, 4, has a negative 2 slope. The other line crosses at negative 2, has a positive 1 slope. So really what you're doing is you're finding that angle. Okay, here we go. The angle that you're finding will be tangent of theta equals absolute value. I'll tell you why the absolute values are there in just a second. And it's going to be, hang on, I'm looking. All right, M2 minus M1, 1 plus, multiply the two slopes. M1 is negative 2, M2 is 1. You would get absolute value of 3. Okay, now this is negative 2 plus 1 is negative 1. Tangent of theta equals negative 3, but the absolute value will make it positive 3, right? Okay, so you have a positive ratio. Positive ratios are always found in the first quadrant in your calculator, so that is why these absolute values are here. The absolute values are there to get a positive ratio, which gives us the acute answer. All right, so what is theta? I believe it was 71 something, 71.6 degrees. All right, you have to punch all that in to make sure I'm right, or that you can do it at least. And that is day 1 of 10-1. Hopefully that helped you out for the juniors that left class early, or even the seniors that wanted to look at it for the second time. All right. Good enough. Will you?